it's all there. Excellent. So, hi everyone, bonjour, I'm Manuel. For those who don't know me, my specialty is dinoflagellate cysts, and my training was really on how to use them as indicators of past environmental change when we find them in the sediment. So this project has more of an oil spill flavor to it, but you'll see an influence from my background as well. Next slide, please. So for this project, we're going to focus on Douglas Channel, which is the body of water that connects the active port of Kitimat to the open waters of the Pacific and international markets. So for a little bit of background and context, Kitimat is one of the major gateways for the export of Canada's energy resources. And given the current projects that are existing and future projects that might be implemented, all of that translates into dramatically increased tanker traffic, or at least shipping traffic in the area, and that for decades to come. So the key knowledge gaps there, and what we're trying to do with this project is first to establish a robust baseline of natural variability in Douglas Channel in terms of, for instance, temperature, dissolved oxygen content, and productivity, and that on seasonal to millennial timescales. And the second aspect is about testing the capacity of local microbial communities to degrade spilled oil or spilled petroleum products, and that under reduced oxygen concentrations and lower pH conditions. So we are considering here the global trend of ocean acidification, as well as limited oxygen availability, which is the case often in all of those seal fjords along the west coast. Next slide, please. So we have quite a few members from quite a few GSC offices from coast to coast, and you will recognize all of the names there. We also have Heather Detman from CanMet Energy, Devon, on board, as well as a couple of people from DFO, so Sophie Johannesson and Ken Lee, and Charles Greer from NRC, as well as Vera Pospelova, who is moving from the University of Victoria to the University of Minnesota, and thus single-handedly making this project international. Next slide, please. So an overview of the project. There are three main components to the project. The first one is about sediment trap time series. This can be seen as a calibration effort, and it allows us to assess the seasonal variability in whatever is sinking down through the water column. So in particular, phytoplankton communities and geochemical indicators. So this helps a lot when it comes to the interpretation of signals we find in the sediments down below. Second component is about sediment cores. So first we have a set of short cores, so box cores, that we will use to reconstruct past environmental variability and trace possible human impacts over the last 120 years or so. We also have at least one longer piston core that we will use to reconstruct past variability over the last something like 4,000 years or so for context. And then using all the results from our reconstructions, we will set up the parameters for our microcosm experiments. So we'll go back at sea and collect some fresh material, that is some water and sediment, and in petri dishes, in incubators, basically, we will run experiments to test the capacity of local microbial communities to degrade spilled petroleum products under a range of, so reconstructed from our reconstructions, and forecast from the literature, oxygen and pH conditions.